Hello, ICS2O folks. You've got a word processor open, maybe Smart Notebook. We will be drawing a couple of pictures, so you might want to use something that you can draw a flow chart. Hopefully you remember what a flow chart is, and we're going to draw a flow chart today. Um, Today's lesson is on loops, and we're actually going to have 3 or maybe 4 lessons on loops, and then that'll be almost it for our first touring unit, and then time to work on the programming assignment. But let's get into the loops. Um, Computers are excellent at doing small steps quickly. Even if it's something very, very, very small, it can do, as long as it's an easy thing. It doesn't have to make too many decisions or too much complicated stuff, that it does it very quickly. And repetition, a computer is excellent at. It says we use a loop to repeat the same steps over and over and over again. So our classic first program was the hello world. So that was a simple step, and the computer's awesome at it. And let's say we wanted the computer to print out hello world a whole bunch of times, 10 times. So, and I've got touring going, and you don't necessarily have to have your touring going, but that's up to you. So one way would be to put hello world and just copy and paste this a whole bunch of times, right? And the computer's not going to know the difference. You're going to hello world, hello world, hello world, hello world, and it'll just do it. But wouldn't it be nice if we could just say, okay, here's my command. Let's just do that 10 times 10. And essentially, that's what a loop is all about. And that's what we're talking about today, is this idea of a loop, a repetitive process. And we have some loops in our real life language, our real life everyday loops. One of them that's a famous one in computer science is washing your hair. So when you wash your hair, if you've ever read the back of a shampoo bottle, it says lather, rinse, and then repeat. Lather, rinse, and then repeat. Lather, rinse, and repeat. Lather, rinse, repeat. Lather, rinse, repeat. Lather, rinse, repeat. Lather. If you actually followed the instruction, you would never ever finish washing your hair. You'd always be lather, rinse, repeat. Lather, rinse, repeat. Lather, rinse, repeat. It's what's called an infinite loop, and it's actually a little bit silly. But a classic example of an infinite loop in computer science. Another one that we might see is climbing steps. Are we at the top? And then if we're not at the top, then we climb a step and we'll repeat. Are we at the top? Climb a step, repeat. Are we at the top? If this answer is yes, we are at the top, then we'll stop. And that would be something that is a loop in our regular day lives, that we don't think about that, of course, but it's this idea of repetitive process, something that's very simple that the computer has to be able to understand. Are we at the top? Climb a step. It can understand. Note, this wordy version of something that happens in real life or our programs is called pseudocode. So it kind of looks like steps: one step, next step, next step, decision, another step, but it's kind of just in words. That's called pseudocode, and it's a way that we'll see soon that we're going to use to plan out our programs when we're solving bigger problems. We'll see that we'll use pseudocode. So another tool that we've already seen is a flowchart. So if in flowchart form, we'd have this one, right? So this is, the square box is just a process. So we'd lather, we'd rinse, and then go back up and repeat, right? This is the loop structure. And notice there's no way out of this loop. This is an infinite loop. There's no decision making, and it just keeps going forever. The other one, which is maybe the more interesting one, the stair climbing one, and again, you're pausing this if it's going too fast so you can do a good job of your note here. Notice the flow of the program starts here, and then it makes a decision. Are we at the top? And if the answer is yes, we are at the top, then we're going to stop. If the answer is no, we're going to climb a step. And then we're going to go back to the decision again. Are we at the top? No, climb a step. Are we at the top? No, climb a step. This is a terminating loop where this decision will help us figure out when to stop executing the loop. And we'll see several ways that we do this, these loops in the next few days. How this works in touring, well, we'll see that soon. In fact, our first loop is, isn't one of these ones where it will work for any flight of stairs. Whether if this flight of stairs we were climbing had 2 steps, it would work. If it had 2,000 steps, it would work. Today we're talking about loops where we know how many steps there are. It'll work if there's 10 steps or 12 steps, but not one or not any flights of stairs. So this is what's called a counted loop. Today we will look at a counted loop. When we know how many times a loop should execute, we use what's called a for loop in touring, and we'll see the syntax for a for loop very, very soon. So this idea is, if we know the flight of steps has 10 steps, then we'll know we'll go, go up a step, go up a step, go up a step, go up a step. If we've gone 10 steps, then we're going to stop. But that same algorithm, that same code wouldn't work for a flight of steps with 12 steps or with 8 steps or with 8,000 steps. That's a different loop that we'll cover in a few classes. So here's the syntax for a for loop. It starts with for, and then this counter is a variable. Often we use I, and then a colon, and then 1 ... And in here, we put the statements that will execute n times. So this loop will start at 1 and count up to the ending number n. Now, n's actually going to be a number. It could be a variable, but we'll see that it's a number. And then the for statement, the for structure ends with an n4. So I'm going to show you this in touring. So for instance, for, and this counter, it could be, often you'll see it just be I, 1 to 10, and then n4. And I'm going to press indent so you can see the touring takes care of all of the spacing for us. And I'm going to run this. There, hello world, printed out 10 times. Bam, just like that. 3 lines of code, 10 copies of hello world. So if I wanted this to run 100 or 1,000 times, all I would have to do is change that number. And you can see it scrolling. It's printing out a whole bunch of times, and sometimes I can see all of the output, but not in this case. So 10. Notice one thing that we can do if we wanted to, and the rest of the note's coming soon. If I wanted to, I could use this variable in my loop. So I'll show you. Say I wanted to print out that number I along with the hello world. So right there. So it's going to print out I. The first time through the loop is 1, then it's 2, then it's 3, then it's 4, and it stops at 10. It's pretty cool. I was 1, then 2, then 3, then 4, and then it stops at 10. So I can use that variable in my statement, and I can do whatever I want to it. Say I want to put in 2 times I. Yeah, I could do that. Then the output isn't very good, but it's going, when I is 2, I go 2 times 1 is 2, 2 times 2 is 4, 2 times 3 times 4, and so on. So I can use that counter in my loop. That's the next thing we're going to say here. We can use our loop counter in the loop for whatever we want, and we'll see all sorts of good uses for it soon. And so we had our example there, and we'll copy that into your notes. Dandy. Remember, you pause if I'm going too fast. Notes. We don't need to start our loop at 1. So for instance, in our loop, if we don't start at 1, I could start at 17 and go up to 100 if I wanted to. So then I would start at 17 and go to 100. Not all of them all fit, but it started at 17. Let me put this a little smaller so we can see that it's going to start at 17. 17, 18, 19, 20. There. Starts at 17 and goes to 20. And so in that way I can count for any numbers that I would like to. We can go up by different amounts using the keyword by. So what does that mean? And by the way, I'll have an example that you can put into your notes. So let's say if I wanted to go from 17 to 200 by 23. That means this is going to count by 23s starting at 17. 17, 40, and I'm, you know, guessing that if I added 23, got out the calculator and punched that in there, that number's going up by 23 every time. Awesome. Great. So it means I don't have to count by ones. I can count by other numbers. We can count down by using the keyword decreasing. So if I wanted to count down instead of up, I would say for decreasing I, that goes from 200 down to, let's say, -7. And I wanted to count by 23s, that would work. It's going to go down from 200 to -7 by 23. And notice that it happened to work out perfectly, that 200 lands right on 27, lands right on -7. But I can count down as well. That's pretty cool. Here's the example. Actually, this little example, notice that I used as my variable counter, I used the word counter, but you could use anything, num, I, x, whatever you would like. And this is going down by 3 each time. So what would this code look like? And I know you can't do this, but I'm going to go back to my program, put that in there. I'm going to comment that part out and indent that so it looks okay and run it. And then there it is, right? Notice that that one did end up on -4 just by coincidence as well. Okay, exercises. Time for you to go back to the website and check out the exercises and save them all up. On next class, we have some more important things that we can do with for loops.